we're good.
Okay, so to start saying, you'll notice I got a little question on the board. I want you to put those three things in order from least to greatest. I got A, the number of stars in the universe. B, the number of seconds since the Big Bang / when scientists consider the beginning of time. And C, the number of possible configurations of the deck of 52 cards. So when I say configurations, I talk about the possible, like, the orders that you can put them in. So, if I had, like, this deck of cards here, a different configuration would be even just moving one card. Or shuffling the whole thing. That would be a new configuration. So talk about it with your partner. Put it in order from least to greatest. You're like, don't worry, I'm not going to be like, oh, you didn't get it right. But just think about it. Go for it.
Least to greatest?
Least to greatest. So the smallest to the largest.
I agree with you.
Dude, I hope you know the same thing there. I hope you know that.
C is definitely not the smallest.
What do you guys think?
I thought it was
We don't know the number
PBD.
of times in the universe.
Well, you don't know any of that. No. If you did, it would be easy. So what do you think? It's just your prediction. What do you think is the smallest?
Wait, do you know the answer?
I do know the answer.
Also do I just said
That's kind of what?
because the universe
Cheating.
is constantly
Well, I came up with the question, so I probably do know the answer.
so that means that it
Okay, this group right here in the middle. What did you say was the smallest?
C, A,
Okay. You're good, you're good. C, okay. Who else said C? Who else thought C was the smallest? Okay, cool. So we thought the number of possible configurations of the deck of these two cards was the smallest. Anybody say something else? What do you think was the smallest?
B.
What do you think? You think it's A. You think A is the smallest, okay?
We thought B.
B. Alright, so we got a little of everything. But, like, in general, most people thought C was the smallest. Okay, how about the largest? Which one's the largest? B, okay. B, I'm hearing a lot of A. Okay, let's talk about it a little bit. Who's good at shuffling for me?
Me.
You're good? I'm terrible at shuffling. So, you shuffle this deck of cards for me.
Three's
Is it
favorite.
because I'm a super senior?
It's because he was quicker than you.
It's because he's better.
Okay, the number of stars in the universe. The number of stars in the universe, scientists estimate, is about 10 to the 23rd. Okay, that means a 1 with 23 zeros behind it. That's about how many stars are in the universe. Okay, the number of seconds is the Big Bang. Anybody want to give a guess?
10 to the 21st.
10 to the 13.
10 to the 13th? Okay, that's pretty close. I mean, kind of. How many in years? How much do you think it is?
10 million.
10 million, that's pretty close.
14
I
billion.
thought it's like 130 million.
14 billion, that's even closer. Okay, the estimate is about 13.8 billion years since the Big Bang. So that's 10 to the 18. So that's 1 with 18 zeros behind it. Seconds. Seconds. 10 with 18 zeros behind it.
I gotta add more.
10 seconds. We could figure it out. How would you figure that out? If I told you the universe
I
is
thought that was
13.
years.
This is seconds.
Well, you're wrong.
Seconds.
It's
It's 13.8 billion years.
Just gotta multiply 10 by itself, 18.
No, what do you say?
You're so super.
Good. How would I figure out if I give you 13.8 billion years? You tell me this is baloney. No way is this true. How could I figure that out?
Google.
Google. How could you figure that out with math? You probably know how to do it.
Take that number. 300.
Somebody say anything? Any ideas?
I'm gonna get one shuffle.
Conversion.
I'm
Good.
trying, but hey, there's a joker. in
Okay,
this.
I heard you say something. You got 365 what?
Days.
Good. There are 365 days in a year. So I can multiply this by 365 days.
Wow.
How many hours are in a day?
24.
Times 24. What would be the next number I multiply by?
3600.
60. Okay, then I've got it to minutes, and then I multiply by what?
60.
60. Okay? That's how you would figure out if this is baloney or not.
Okay, what is it?
Okay, any guesses for how many ways you can shuffle? Just shuffle it one time. You can take the joker. That would help.
200.
Yeah, Reese.
831.
256,831.
How'd you go with that, right?
I don't know.
I like it. I like just throwing out a guess. Okay, that is way too low.
Wait,
It's a little higher.
Way too low.
1.5
You have to do 52
million.
times 52.
1.5 million. Way too low.
95.
Too low.
Way too low.
3 million.
Way too
52 to the exclamation point.
1.2 billion.
Nah. 24.
What'd you just say?
52 to the exclamation point.
52 to the exclamation point.
What's that? That's 40?
He's right about that. We're gonna talk about that later. 52 to the exclamation point. Do you know what that
Man,
means?
you should be at the match.
52.
What the heck?
52.
52. This is called 52 factorial. Okay, what this means is, this means, if you see this math, it means 52 times 51 times 50 times ... all the way to 3 times 2 times
Yeah,
1.
how'd you know that?
Because I'm built different, obviously.
Okay, how did you know that?
I don't know. You
Because
raised a lot like that.
He's a big match.
You didn't just guess. How did you just guess? How did you know it was 52?
Oh, well, because there's 52 cards.
Good, there are 52 cards. So, how many possible cards can be in that first position? 52. Okay, I just used one. How many can be in that second position? 51. How many can be in that third? 50. Okay, I keep going until I get 3 times 2 times 1.
Do it
Hey, if you do that with calculator, are you doing it? Do you know how to do that on your calculator?
I was trying to do the billion.
Okay, you get something that is like 10 to the 68.
We had the order.
Oh,
so
so
I
I
was right.
To the 68. So which one's the biggest?
Sure, what's the name?
BAC?
Yeah,
Which
we
one's
were
the
right.
biggest?
C.
C. The number of possible configurations of a deck of cards
I
is
like
bigger
that.
than all those. Okay, let's talk about what that means a little bit. Reese just shuffled my cards for me.
Like 8 times.
Like 8 times. How many times did it take you to shuffle it like once? Or like how long did that take you? Sorry.
Like 5 seconds.
It took him like 5 seconds. Okay, it took him 5 seconds to shuffle it one time. Okay, what does this mean? What does this 10 to the 68 mean? Okay, 10 to the 68 is bigger than how many seconds there have been since the Big Bang.
Wow.
Okay, so let's think about that. If Reese started shuffling since the Big Bang, every single second, if he shuffled every single second, he still would not have hit every single configuration of cards.
Wow.
Isn't that crazy? So, if you shuffle a deck of cards, it's pretty likely that that is the first time a deck of cards anywhere has been in that order. I know, it feels impossible.
Me and Reese, David.
Man, you're special. Yeah, I did that, guys. It hurts my
But it's true.
Yeah,
Okay,
give it to me and I'll
the
do
reason
it.
I wanted us to talk about this is deck of cards are going to come up a ton in stats. Like we talk about them all the time.
I'm just kidding.
Okay, Marcos drew the first card, right?
Yeah.
And he was trying to get the King of Diamonds. Okay, I'm trying to get, I want to know the probability of getting the King of Diamonds on the first draw and getting the 5 of clubs. I want to know that.
It's impossible.
It's not impossible. It could happen, right? They could draw, right? Okay, what was the probability of getting the King of Diamonds?
1 to 52.
1 out of 52, good. There's only one chance out of 52 cards. Okay, I have the word and. You're going to find out in stats, and a lot of times means multiply. Okay, so what was the probability of getting the 5 of clubs? Given that, okay, for him, given that that one card was already taken. 1 out of 51. Good. So let's talk about what if Marcos had chosen the right one? Okay, let's say that was lucky. What if he had chosen the right one? Okay, what was the probability that Adrian would choose the correct one? Good. Still, it would still be 1 out of 51. Okay, so would you agree this probability right here is the same as the probability of getting the King of Diamonds times the probability of getting the 5 of clubs given that he just got the King of Diamonds. Okay, the probability of getting a King of Diamonds and the 5 of clubs is the same as getting the King of Diamonds times getting the King or the 5 of clubs given that he just got the King of Diamonds. Okay, that's just something to think about. So, what did we just learn there? I just learned the multiplication rule.
Well, it's
The multiplication rule says, the probability, you're gonna wanna write this down, it's in yellow, remember, it's in yellow, we're gonna wanna write it down. I give my cards down.
I like that.
Alright, I want you to find the probability that a randomly selected Sioux Center student goes to either homecoming or prom. Goes to either homecoming or prom. 72% of the students go to homecoming. 42% of the students go to prom. You guys have prom here?
Yes.
Okay.
Oh, get math done.
Alright, everybody stay with me here. Why does it make sense that more students would go to homecoming than go to prom? Homecoming's more fun, maybe.
All the students go.
Good. All the students can go to homecoming, only some of the students can go to prom. Okay. In stats, this is very important to remember. In stats, Venn diagrams are going to be very helpful to you. Venn diagrams. Anybody remember what a Venn diagram looks like?
Two circles overlapping.
Good. Two circles overlapping. So, I'm going to draw a Venn diagram. Okay, I'm going to say one of them represents the students that go to homecoming. Okay, so any student in this circle went to homecoming. And let me say another one represents prom. Any student in this circle went to prom. Okay, what would the overlap be?
Both.
Both. Okay, how would I figure out this circle is 0.72 and this circle is 0.42? How would I figure out how much this whole Venn diagram is? Any guesses? Don't be afraid to be wrong. Okay, what's kind of making you think that it might be more than 100%? Okay, so you started adding them, right? So you said, okay, 0.72 plus 0.42. Anybody have their calculator? What's 0.72 plus 0.42? Or who can do that in their head?
1.14.
1.14. Good. 1.14. Okay, what's wrong with that? What rings a bell there? I can't have a probability greater than 1. I can't be 114% sure. Okay, so what did we do wrong there?
We added it instead of, we used to.
You didn't consider if they went to both. So we counted all of these students. And then we counted all of these students. So we double counted this middle section. So I gotta somehow subtract this middle section. I left this out on purpose. I need to know how many students went to both. I got that 27% of students went to both.
What about the people that didn't?
So how would I figure that out? I do 0.72 plus 0.42 minus 0.27. 0.87. Everybody agree with that?
13%.
Okay, so that tells me 87%. That tells me 87% went to either homecoming or prom. Okay, somebody just asked a really good question. What about how many students didn't go to either one? How would I figure that out?
13%.
The 13% left over. If 87% are in one of these two, 13% are outside. Or 0.13. I need it all to add up to 1. So what did we just learn there? If I say or, I use addition. Okay, and means multiply a lot in stats. Or means addition.